right, guys, this is going to be the video recording for phase change, pretty much the rest of chapter 1. So it's a combination of 1.4, 1.5, and 1.6. I kind of cut out things that were repetitive because we already kind of have the baseline of knowledge for this unit since you all did it in 6th grade. So I kind of tried to pick and choose what you needed to know and what we don't need to go over. And so today we further our kind of investigation into the molecules of our different states, so our solid, liquid, and gas, and how those molecules are structured and how they move about in each one of those phases. So going to our assignment for today, which is linked. Oops, it would go up. There we go. And so what we did in class, and we did a jigsaw. So if you missed class, you're going to unfortunately have to do this all on your own. We looked into weird water events. And down here, you're going to see that there are 5 different ones. And so there is weird water, flash floods in Slot Canyons, glacier caves of Iceland, frozen Niagara Falls, and Old Faithful. And so each one of these is a hyperlink, so it will take you to the article in Amplify. And there's some cool pictures and stuff that go with each one. Up here in the top in the instructions, I gave you some things to think about when reading. So what phase changes are occurring? And what does that look like? And we talked about the macro scale and the molecular scale. Remember, macro scale would be this, what we can see with our eyes. So we can see the iceberg, glacier here, which is solid. You can see the water down here, which we know is liquid. We know that the air is made up of gas. And so this would be the macro scale, and then this is the molecular scale, what each of those molecules will look like in that state. And so we know in a gas state, the molecules are moving around, they're moving away from each other, and they're moving fast. In a solid, we know they are close, they are locked together, and only can move in place. And then the liquid, they are moving and they flow around together though. And so you will look at each one of these and fill in. And then freedom of movement is kind of another idea that ties into those different places and the movement of each of our states. And so right here, I just wanted you to kind of tell me how each of these states have their molecules move. So how do the molecules move in a gas? How do the molecules move in a liquid? And then how do they move in a solid? And then I kind of started doing this with the last group. But there are 3 modeling tools here that are all hyperlinked. And so you're going to want to use each one for the boxes below it. And so you're going to click here on that modeling tool. And for all 3 of these modeling tools, what they're going to do is they're just going to help you create a visual. And then based on the visual that you create, you're going to then fill in the boxes on the doc based on what you came up with. And so hopefully it will load. There we go. And you're going to see I already filled this one in, so yours will look a little different because yours is not filled in. And so here is the modeling tool, and we are modeling the popsicle and what it would look like before and after it melts. And so we know before the popsicle melts is going to be a solid. And so you click these little blue pencils up in the top corner, and you're going to choose, and you can see I already chose, how the molecules will move in a solid and then what that's going to look like. They're rigid and they hold their shape. And so that is the solid. And then you're going to look at what it would look like after it melts. And so we know when it melts, it goes from a solid to a liquid. And in a liquid, the molecules are moving around each other, but they're still staying close by because they will flow together and take the shape of the container they are in. And so looking at that, you will then fill in your questions. And so I kind of started it to help my last group get started. But thinking about the molecules, describe what they look like before it melts and what state of matter is it in. So before it melts, it's a solid and those molecules are barely moving and staying in place. And then after it melts, it's a liquid, and then describe how those molecules are moving. And also think about what causes the popsicle to change phases. What is happening to cause most things to change phase? Down here, there are two other modeling tools. And these modeling tools have to do with our scenario that we're looking into, and that's Titan and the lake on Titan and how it disappeared. We're looking into if it maybe froze or if it evaporated. And so each one of these scenarios will look into that. So this one is looking at if it froze, and then this one is looking at if it were to evaporate. And so you're going to kind of use the modeling tool, and it looks very similar to the one I just showed you, and you're going to look at how those molecules are moving and how they're going to change. So example up here, when water freezes, it's going from liquid to solid. So what's going to happen with those molecules? How are those molecules going to change? Are they going to slow down, speed up, move around more? What is that difference going to be?